little tour of the night sky with Stellarium, which he normally does at the club meetings. Then Ray is going to open up his dome. He's trying to keep the ice off a bit off of the telescope at the moment, I believe. So it's about -5 at the moment. It's getting a bit nippy, I must admit. And he's going to show us a bit around the moon. And whilst he's doing that, I'm going to reposition this telescope, and we're going to try and have a look at Mars, depending on how good the seeing is at the time. Then we'll go back to Ray. He's going to look at another portion of the moon. And whilst he's doing that, we're going to come back to Jupiter. Because Jupiter, by that time, the great red spot should be, let me just go on the other screen and I'll be able to point properly. The great red spot is just about here at the moment on the limb of Jupiter, and it will be transiting across the front of the planet. So we'll be able to see the great red spot within about half an hour to an hour, something like that. Very dimly at the moment. You can just make out Io and Callisto, and Ganymede is, I might just zoom out a little bit. What I'm going to do is I'm going to show you the moons at the moment by turning the gain up a touch. Ray, if you can just let me know if the image goes a bit weird when I come back down, when it's good.
A bit more pink. Yeah, there they are. That's some ball bang on.
Yeah. Okay, so what we've got here, we got Io is, make sure I get this right. Io is just here. This is Europa. And right over there, we have the largest moon of the solar system, which is Ganymede. Let's say, round about 9:05, if we're still going, Io is going into eclipse. So everything's rotated. Let's say that Ganymede here is coming around this way. Io is going around that way. And it will go in behind Jupiter. And then not until about I think at 2 o'clock in the morning, it then comes out of the shadow of Jupiter, just about here. But I think I should be well in bed by that time. I'm just going to zoom out and see if we can pick up any other moons. I don't think we can at the moment. The camera is a little bit too small, a narrow field for that. Nope, we can't. So say to get the moon showing, we've really got to overexpose Jupiter, because obviously the moons are much, much dimmer than what you will ever see as of the planet. So we'll just go back to the planet at the moment. So I'll bring the gain back down. Is that looking good, Ray?
That's about right, Pete. Yeah.
Yep, looking good. Just reposition the telescope in a minute. And we can zoom in. You can actually make, for your better viewing for yourself, on Google Meet here, there is a little icon, like a little square icon. If you click that, you can make the image you're looking at full screen, which will probably be better for yourself, especially if you're on a mobile phone or something like that. So say we can see here the northern and southern equatorial bands. Now the image here, because we're using a refractor, is the right way around, but upside down. So this is north and that is south. Okay. And so when the seeing gets steady, now and again, you can make out the larger northern equatorial band and the slightly smaller southern equatorial band running along there, and there's another one below that. Just going to play around with the gain so we can bring stuff out a bit better. Take the gloves off, that'll make life easier. Is that looking good, Ray?
Yeah. It's actually, it looks at your end that the scene's very good. Unfortunately, here, a few miles away, it's not nearly as good as that.
We're actually getting better than what we thought we were going to get, though, weren't we? We thought it was going to be totally clouded out all night. So, we're lucky to actually be able to do this. So there we go. Here's Jupiter, giant of the solar system. Also known as the vacuum of the solar system, because any sort of debris that's coming in, asteroids, normally get swept up by Jupiter. I don't know if anyone was lucky enough back in late 90s to see Shoemaker Levy 9 crash into Jupiter, but that was absolutely stunning.
It's one interesting fact about it as well is that you could fit all the planets in the solar system inside Jupiter quite comfortably.
Yeah, it's huge, isn't it? And so a lot of people think that sort of Saturn is one of the better planets to look at, but also sometimes Jupiter, when you look at these bands and you can see that you can actually today, which is unusual, you can actually see the actual structure in the clouds when the seeing gets good. Seeing is a very, very big part of astronomy, visual or camera astronomy. For how stable the atmosphere is makes a heck of a difference to what you can see in the image. I say when it's really bad, it's like looking at something on the bottom of a swimming pool or through all the water. Sometimes when you come out of bed, it looks a bit better.
And again, for those people that are new to astronomy, this is actually one of the planets you can get a really good view at with binoculars, in particular its moons. So if you've got binoculars and you've got a clear sky after this, then go out and have a look and see how the moons...
Tonight is very, very easy to find Jupiter as well. It's right below the moon. Right below the moon there. So we have now sort of 5 minutes, I think, on here. Ray, if you want to start your bit?
Yeah, I think if Mick starts, I'll head outside and break the exposure. And I'll be back shortly. So Mick's going to do a quick sky night.
Mick's next, yeah. So Mick, are you ready to do your night tour?
Yep, sure.
Give me a second. I'll just end. Let me know when you're ready. I'll just end this share then, and you can start yours.
Yep.
So what Mick's going to do is give us a tour around the night sky with his sort of stellarium. So when we finish this, you can all put your coats on and your hats on and your gloves on. I've got mine on. And you can jump outside and have a look around the night sky. I do have heaters in here, by the way, but unfortunately, if I put it on, the seeing goes terribly because all the heat goes straight out the hole of the observatory. It makes the seeing through the telescope awful.
Okay, so Happy New Year to all, and a warm welcome to Sigma's January 25 edition of our Moray Sky at Night, an abbreviated version tonight, because I'm only going to concentrate on the solar system and things you'll be able to see in the night sky this month. Most of the stuff that I'll be talking about, in fact, everything I'm going to be talking about, you're going to be able to see with the naked eye. But a pair of binoculars on some of these objects is going to open things right up. And a pair of 10 by 50 is the kind of recommended spec for a set of binoculars if anybody's looking for some. So as you can see here, I'm using a program called Stellarium. There are others available, but it's what I've chosen to use and what we normally use in Sigma. It's free for any computer system, and you can get it on your phone, on your tablet. I believe there's a fee, maybe a tenner or something for iOS. So if you've got Apple, but it's well worth it. It's a one-off payment, and that's you got it, and it updates itself. So I'll work through the month, explaining things as I go and covering all the planets. So starting with meteors. So this month, the quadranted meteor shower, which started the 28th of December, is continuing, and that peaked on the night of the 3rd into the 4th of January. It continues, though, up until the 12th, and the radiant of it is here. So if you look to the north, basically anywhere above the northern horizon, look out for meteors, and that should be quadranted meteor, but that's the area of it here. So for the planets, inner planet Mercury, if I go back to 9 o'clock in the morning, I'll just show you where it's at. So down to the southeast. So this is just before sunrise this morning at 9 o'clock. As you can see, it's way too close to the sun for any observing to be carried out. If I put the atmosphere on, this is kind of what the sky would have looked like. So you can't really see it, and it's not worth looking for it with anything at the moment. And certainly don't go pointing telescopes and binoculars at it, because you will damage your eyes if you catch the sun and those bits of equipment. Going to tonight, as Ray just said, this is our sky. If you look at it, 9 o'clock tonight. I can put it to the current time, but it's kind of close enough. As you can see, the moon's right above Jupiter in Taurus. Going to the 11th. The next planet out, Venus. Most of you have probably noticed that this is very prominent in the sky at the minute. As soon as it, in fact, before it even gets dark or before the sun sets, you can see this shining brightly out to the south. And this comes to its greatest eastern elongation from the sun tonight, actually, when it'll be visible. It's visible at a magnitude of -4.4. The dichotomy, which is the half illumination, that occurs on the 12th at 2 o'clock in the morning. So if you look at it on the 11th, the evening of the 11th, that's the closest you're going to get to that. And if I zoom in, or if you get a telescope on Venus, this is what you'll see. So it's pretty much 50% illuminated there, known as the dichotomy. So moving further out, we are the next planet out. So planet Earth, we reached perihelion, which is the closest point to the sun in the yearly orbit, back on the 4th of January at 2 p.m. And we were at a distance of 0.98333 astronomical units from the sun. Going to the 12th, out to Mars. So Mars reaches perigee, that's its closest point to the sun, on the 12th of January. And then it will be 0.64 astronomical units from Earth. On to the 13th of January, we'll be able to see a full moon right next to Mars. And on the 16th, if I go to 1 a.m., so the 16th at 1 a.m. is the best time to have a look at Mars, because it's going to be at opposition. So 1 o'clock on the 16th. Obviously any time but before or after should be fairly good as well. And tonight it's looking pretty good, as long as the weather behaves. On to the 20th at 17. Oh. So Saturn, sorry, I've just skipped Jupiter, but you've seen Jupiter there, as Pete's just been talking about. So that was the next planet out from Mars. And the next one out is Saturn. So that, as you can see here, is an Aquarius. And you can see that just after sunset, most evenings at the moment, especially once the dusk light starts to disappear. On the 20th of January, so Saturn and Venus will be 2.2 degrees apart. Venus obviously being the brighter of the two, a magnitude of -4.5, and Saturn a magnitude of 1.1. And on the 21st, so these are just some possible photo opportunities that you might want to catch. You know, a couple of planets next to each other. And if you've got a wide enough field of view, on depending on what camera and lens you're using, you could probably catch 1, 2, or you could catch 4 planets there, look, in the same field of view. Where was I going to? 21st at 2 a.m. Be able to see the moon, last quarter moon, in fact, right beside Spica in Virgo. Moving further out, we have, let me get my bearings right here. Where are we? Go back to 10. Where do we get to? Saturn. So Uranus is the next planet out, and that's sitting up here. It looks like it's in Taurus. If I put the boundaries of the constellations on, you'll see it's actually sat in Aries. So that ends its retrograde motion on the 30th of January at magnitude of plus 5.7. And finally, Neptune is in Pisces. I'm going to have to come back a little bit in time here. Some of these. Just going to find this down here somewhere. There we go. Neptune, the outer planet in the solar system, is at magnitude of 7.9, and that is now setting earlier in the evening towards the end of the month. So that's the solar system tour. What I'm going to now show you is a good way to find your way around the night sky. I'll go back to tonight. I'll go at 10 p.m. South. So what I'm going to show you is a good way to find your way around the winter night sky. So this is what is known as what we call the Big G. And I've taken this from Bill Leslie's. I'm pressing the wrong buttons here. Right. I've taken this from Bill Leslie's Winter Sky Notes, which, if you're a Sigma member, you should have received a couple of months back, or last month, I think. I sent out a copy of that out. So this is the Big G I'm going to talk about. So looking to the south in the winter, there's quite a lot to look at, especially this year, as we've got Jupiter and Mars in amongst it. And tonight we just happen to have the moon in there as well. So starting at the 3 stars that make up the belt of Orion, we follow these up till we get to this red giant, bright orange star Aldebaran, which sits in Taurus. It sits in an asterism, which is part of the constellation Taurus. And the asterism is known as the Hyades, which is this V shape here. Although Aldebaran looks as if it's part of this V, it's nowhere near the distance. It doesn't actually. So Aldebaran is 66.6 light years away, but all the other ones are in the hundreds, 150, 160, 170, 146 light years. So it just looks like it is part of them. But it is part of the Hyades, as we know. So starting at Aldebaran, to start drawing our big G, what we do is we head up about 30 degrees to Brilliant Capella, which sits in, it's not a pentacle, but they've actually drawn an extra star on this, but sits in Auriga. So this is at the top of the G. And to know that you've found the right star there, there's actually this little triangle of stars here, which are known as the Kids. So if you found these next to it, you know you've got Capella. So then we come down as we start drawing, continue drawing the G down through Castor and Pollux, which sit in as the heads of the twins of Gemini. Then we follow it down to Procyon, which sits in Canis Minor, down to Sirius, the dog star, in Canis Major, which is the brightest star in the sky. Back up to Rigel at the foot of Orion, up to Bellatrix, and finish off the G at Betelgeuse. So you can see you've covered quite a bit of sky and taken in quite a few constellations there. If you want to start learning your way around the night sky, it's a good place to start. And that's pretty much all I want to say, unless anybody's got any questions they want to ask me. Not that I'll be able to answer them all, but I can have a go.
I was saying, Mick, do you want to just point out the Great Orion Nebula? That's a great thing to see with sort of binoculars and zoom in on it a little bit.
Yeah, I can do that. Let's get some of these lines out of the way.
Not on that section.
So this is Orion Nebula. Let's get some information for you. Oh, it's picking the wrong number. It would do, wouldn't it? There you go. M42. That's some information up there for you.
Just zoom in a bit so we can actually see the details. This is a great one. If you're new to astronomy, this is a great one to start with because it is actually visible to the naked eye, isn't it?
Yeah.
So you get a pair of binoculars is all you need to see it, and you'll see some wonderful structure just with a pair of binoculars. See what this is over there. And if you're lucky enough, if you've got something like a set of 20 by 50 or something like that, you might actually get to see the four stars in the middle, known as the trapezium, which is it's like very, very young stars that are being formed within inside that nebula. It's a great thing to see if you haven't seen it before. I recommend you go and do it. Right. Yeah, thanks for that, Mick. As I say, that was great, because as you're doing that, I've looked at the hatch in the observatory and following it around the sky. It's brilliant. Okay, Ray, are you ready for your moon, or...?
Okay, so what we've got here is the view from my observatory. I have the luxury of having remote access to everything that's going on inside it from inside the house, so consequently I'm nice and warm, and I can have a nice gin and tonic. And
you're very, very lucky. I'm just going to move the my scope now onto Mars, so I'm going to mute myself for a minute, so you won't hear me.
This is a view inside the observatory. This is the camera. This is the club's 9.25-inch Schmidt-Cassegrain telescope, which is a bit of a dew magnet. And unfortunately, where I am, probably about 9 miles from Pate, there's a lot of high mist. So doing any planetary imaging is completely the question at the moment. But the moon is a lot more forgiving. So that's what we're going to concentrate on. So this is the view of the moon that we've got. See if we can actually get this a bit better. No, there we go. Right, does that look better to everyone? Okay, now this thing at the side here is basically allows me to control the position of the mount, so I can actually move the view back and forth, which is actually really nice. That means I don't have to be outside in the perishing cold. So let's just turn the brightness up in this, for want of a better word. Right, so what we've got here is a view of a crater on the moon called Copernicus. And you can see it's quite an interesting shape. It's actually got a tiered walls of the crater, and it's got a few mountains in the center here. And right at the edge of it, this area here is the Apennine mountain range. And if I move the telescope to the west, Ray, to the west, what we've got is this. You can just about make it. I don't know if you can see this little dot here, and there's a suspicion of a little line. This is a crater, and there's a little, what they call a rill. It's like the Grand Canyon. It's about 1 kilometer across. So, we're actually able to discern detail about 1 kilometer across from this telescope. And this is Mount Hadley. Okay, so this is a mountain. And right here, where my cursor is where Apollo 15 landed. It was the first one to carry a lunar rover with it. And they did a lot of exploration around this rill. And as I say, the pictures you see of it with this mountain in the background. So they actually had to fly in over the mountain range and then drop down into here. And this thing that's about the size of a telephone box. I think they had pretty big cojones. You wouldn't have got me up in that, but never mind. So that's the Apennine mountain range. And if we go north, say north a bit. There we go. We're moving into what's called the Mare-Imbrium Basin. And this crater here is called Plato, and this is where the Chinese landed their little, I forget what it was called, I think it was the Chinese word for rabbit or something, but it landed and a little rover came out and took some photographs, and I think it was about here. But despite the cloud, we've got some actually some quite nice detail here. Actually, the atmosphere is quite still, but the problem is where I am at the moment, there's a big high mist, so trying to get something further away, and this sort of detail is going to be sort of problematic. So the plan is that we'll continue with Pete's, as we speak, is going to be moving his telescope onto Mars, and then hopefully we'll get a view of that. And then what I'll do is I'll switch to other areas and then. So we've got quite a lot of detail. There's a little mountain range here. And as we look over to the Terminator, basically we're starting to get a lot more detail because of the shadow. And then we're back to Copernicus. I almost said Copernicus, but no, it's and the interesting thing is we've got you can see the ejecta that's come out from this crater. All the material's been thrown out from it, and you've got more mountain ranges around this area. And again, we can move further south of it. Right. So this area here, if I'm right, I've got my bearings right. Yeah, I think it's round about here. Is where Apollo 13 was supposed to land, for a Moray region. It ended up being obviously Apollo 14 that landed there, because obviously there was a explosion on the spacecraft on the way out to that site, so it didn't get to land. I think, if I remember rightly, again, if I'm talking rubbish here, please let us know. I think this is crater Gassendi. And again, we're right in the Terminator, so we're getting some nice details surrounding structures and things that are there. Again, sort of moving north. We can move east. Sorry, west, I beg your pardon. Right, okay. Right, so this area here is Moray Tranquility, the Sea of Tranquility. And Apollo 11, if I remember rightly, landed around about here. And since it was the first manned lunar landing, they really weren't, it's not that they weren't interested, but they chose what they considered to be a fairly benign landing site compared to later missions like Apollo 15, which, as I said, had to fly over these horrible mountain ranges and drop down. I don't have quite the power on the telescope at the moment to actually show this up better, but it's around about here from what I remember, this region here. And of course, they overshot the original, the planned landing site because of a computer glitch on the way down. And again, moving west, we have Moray Crisium, crisis. And for those of you that attended our last broadcast, we watched the occultation of Saturn. The moon passed in front of Saturn, and Saturn emerged from behind the moon, round about this region here. So, but actually, the other night we actually caught. And for those of you that aren't in the club, if you go on our Facebook page or our Flickr account, you'll see some pictures of Saturn as it came from behind the moon around about here. How are you getting on, Pete?
Yeah, I'm lined up on Saturn, on Mars.
What are the chances of anything coming from Mars?
very slim.
Isn't that 1,000,000 to 1, he said? Something like
One,
that?
yeah, something like that. It was kind of War of the Worlds, must have been.
Yeah.
Yeah,
So,
I'm good to go if you're good to go.
yeah, just finish up here to the north.
There is some detail showing on Mars, but it's there. So you'll see what I mean about, about the seeing, what I said about the seeing in a minute. Because Mars is much lower down, so it's going to be coming through much more atmosphere. Once I get to share, you'll see how shimmery it is.
From what I saw, is we should get a view of Syrtis Major, a sort of V-shaped structure.
Yep. Do you want to end your share?
Yeah, I'll sit there and I'll try and find something, another region with something of interest in it while you're looking at Mars. So there we go. I'll stop presenting.
Right. So from the Moon to Mars.
Sounds like a movie. Yeah, there's Syrtis Major, Pete. You can see it's like a V shape.
Yep. Yeah. Just I'm going to zoom in a little bit.
You can see the polar cap. Oh, yeah.
So you can see it just about here, yes?
Yeah, that's it. Yeah.
And I think when the seeing goes fairly steady, you can actually just make out the northern polar cap as well, just down there. Yep. Now what I'm going to do here is I'm going to show you a little bit about how you take images of planets. Because you just see, if you remember what I said about Jupiter with the seeing and how good the atmosphere, how steady the atmosphere, the Earth's atmosphere, that is, is. Because Mars is much further down, it's coming through a thicker part of the atmosphere, so it is shimmering around a lot more than Jupiter was, you'll notice. But what we do to take images of the planets is we take a little video. Now this software I'm using is the ASI software that comes with the ZWO solar system camera, which is the one I'm using up here. I won't move the scope just in case I lose the camera connection. This way, I won't move the laptop just in case I lose the camera connection. I'll show you that later on. So what we do is you set up your gain and your exposure, just so you get the best image that you possibly can. So gain is basically the same as the ISO that you would have with a SLR camera or something like that. The higher the gain, the noisier the picture is going to be. So it's a case of mixing around a little bit there to what's best and what you get better. In this software as well, what you can do is you can choose what format you want, but it always does it in RAW. Very big files in that case. And you set up your resolution and stuff like that. There's a few items up here I'm not going to go through tonight. We haven't really got time, and it is getting cold out here. I do envy you, Ray, and all you other people sat there looking at these images. So what you do is you choose how many frames you want to take. I've got it set for 500. These controls at the bottom is just basically for your screen controls, how bright your screen looks, stuff like that. And I find leaving them alone is quite a good idea, or else it all goes totally wrong, unless obviously your image isn't looking really good. But you see, it looks absolutely awful at the minute. So what I'm going to do is going to wait until it settles down just a touch, and then we hit the video button. And what that will do, that will now start taking 500 images. And then later on tonight or tomorrow, I will put them through some software, possibly Ready Stacks or something like that, one of the other newer ones that are out there. And it'll stack each one of them images together, and it'll take away the fuzzy frames, and it'll only stack the good ones. And I say in this software as well, just at the bottom, you can see how many images are being taken. It's 447 already. And if they've got any really bad ones, it'll just discard them, and it won't actually take any. So that's it. That's the 500 frames taken. And to say that I'll store it in a folder in here. And sometime tomorrow, I will get that processed. What I might do as well for the members here, Sigma members, if you're interested, maybe you can give me a hands up. I could put this into a drive, and if you wanted to download the file yourself, you could do and have a go at stacking. If you're interested in doing that, let us know. So I think that is probably one of the best images I've actually ever had of Mars. Don't it yourself, Ray? I find Mars quite difficult most of the time.
The scene's got to be very good. It's the scene at your end is clearly a lot better than here. There's no way I could get anywhere near that in here tonight.
Yeah. And so when you're observing, sometimes if you try and go too big, it just it really does just sort of spoil what it's in. Actually, that does, when it goes steady, you can really see that. The polar cap there, that's for sure. Let's say sometimes don't try and overstretch things. You know, sometimes a smaller image gives you much more detail. I'm pretty sure we won't get Phobos or Deimos because they aren't big enough because only try to really capture that.
Actually,
Phobos and Deimos is the two.
Could you overexpose it? Because I think Phobos is visible about 2 o'clock.
Is it? All right, we'll give it a go. Then we'll turn the gain up and see what happens.
Maybe not. That's
no. They're very, very small, aren't they? They're tiny. I think you need a better seeing than what we got here. As you can see with this gain here, that as you put it up, it really overexposes things. And you just got to play around with it a little bit until you can get the best image you can. Or you can play around with the exposure as well, obviously. That's not looking too bad. Maybe. No, I think that's pretty good for Mars. Very good indeed. What I might do is later on, when it's a bit higher, if the sky stays clear, which it is at the moment. Never expected that. I might try and do another couple of videos and see what we get from that. Okay. Anybody got any questions about Mars you want to put in the chat or anything? And we'll try and answer them. Obviously, years back, they thought Mars were, was inhabited with vegetation because when they first seen it, all these details, sort of, look like canals. They were called canales, and they thought they were being built. Let's not say human built, but built by some being out there because they were too straight to be seen. Too straight to be sort of natural. They thought, when they seen them. If you want to put any questions in the chat, we'll try and answer them through there. It's looking pretty darn good now. Let's reposition it a little bit. I'm not seeing any chats yet. Hang on, what we got here. Tommy says it looks very nice on Stellarium. Okay. Does it look as good as Stellarium or better? Because it's live. So looking at things digitally, saying sort of like this is good, but I still get a buzz from actually looking through the eyepiece, I must admit. And if you've never done that, hopefully, they say this was meant to have been a public event where we have telescopes and that out, and hopefully we'll get that reorganized, and we can then get somebody down there and look through a telescope. When this year will Mars be closest was that I think Mick said that it's going to be on the 16th of this month.
Yeah.
That's what's called opposition, is when it's at the closest to the Earth. Opposition means it's on the opposite side to us to what the Sun is, and that's its closest point to us. What would the image be like using Mark when I go through telescope? 1 second. better or worse. Obviously, with your Mark 1 eyeball, you can't zoom in, so you've got to put some magnification up. So once again, it all comes down to the state of the the atmosphere and the seeing. You get a really good still night, you can actually put a Barlow in and get the sort of magnification up that way. But as I say, Mars I've always found quite awkward to get unless you have really good really good seeing, and also now is the best time to do it when it's at opposition. Oh, that's Martin, is it? As in Martin de Vries. As I say, what we'll do later on, once we've finished here, we'll put the microphones on, so I'd like to get a little bit of feedback from everybody. At the same, and we can have a bit, have a bit of a chat if you want to. Right, if we're done with Mars, are you happy to go back to the moon, Ray?
I'll need about 5 minutes, Pete.
No problem.
Something's timed out here, and I need to reset it.
The usual Sigma IT glitch, that's normal.
Right.
So could I just have a show of hands of how many people are visiting us tonight rather than members? Yeah. Oh, great, and I hope you're all local. Let's say hopefully we'll have a bit, have a little bit of a chat later on. We've got these sort of microphones off because it's so easy to leave a microphone on and it can interrupt the actual stream. But we'll put the microphones on towards the end, and we'll have a bit of chat and answer any questions that you might have. Now, how do I lower these hands? That's the next question. You might have to do them yourselves. Right, let me just go back to here. Seeing seems a bit better. I'm just going to take one more image and say what I'm going to do is once I get these done, we'll get them shared on Facebook and everything, and along with the members. And you can see the difference between what you see through a camera and through your laptop or telescope, through your sort of computer, to the final image of you get when you stack the images. Yeah, that is definitely the northern polar cap you can see there, without a shadow of a doubt. Just to remind you once again, obviously through the telescope, everything's the right way around but upside down. So north is down and south is up. My feet are getting chilly now. I do envy Ray, I must admit. There's another little thing you can do. You can cheat a little bit because you can image. When I say image the sun, you've got to be very, very careful doing that. If you're using an ordinary telescope, you've got a full white light filter over the end of the telescope. You can actually put colour into it if you want to. And that actually looks better. It's false colour, but it does show up the details an awful lot better, I think. The other trick you can do is to use filters. There's different filters you can use. You can put in between the camera and the telescope. And certain kind of filters bring out more detail than others. But for Mars, it's always good to use a red filter. It brings out more of the red colour. But you can use that visually as well, not just for the camera. For visually, why someone asked what's like with Mark 1 eyeball. Filters is always a good idea to use when you're looking at the planets. As I say, it does actually enhance the detail a little bit. So I'm wondering if Ray has sorted out his IT issue yet. We always have.
Nearly, I think.
Nearly, you say?
Yeah, ready to go. Right.
Okay. I'll end this share, and then what we'll do, I'll go back to Jupiter, and if we hang around long enough, we can watch the. There's another hour away yet, so we'll try and fill in. We'll have a chat or something, and then maybe I'll have a cup of coffee. So that'll be a good idea. Let me just end my share if I can.
Can everybody hear me? Okay. Right. So what I've done is I've moved the telescope to the south, and sorry, I'll start again. What we've got here is, if you've ever seen the film 2001: A Space Odyssey, this here is crater Clavius. This is where the big moon base in the film was supposedly constructed over. So it's the second largest crater on the moon, the near side of the moon at least. This is this one here. I'll just move this north slightly. Right, this crater here is Tycho, and it was formed by a large asteroid that hit the moon. And if we actually zoom out, I don't know how far I can zoom out, but at the right illumination, you can just about make out rays of ejecta that are emanating from it. See this part of it here that's part of the ejecta. So when the asteroid's thumped into the moon's surface, it's basically splayed out lots of material, which again you can just about make out here. I think this is crater Schiller. I've forgotten what these are called, but again, if anybody can remember and want to put them in the comments or put your hands up, that's absolutely fine. So moving further south, again, you can see there's a lot of craters around here. It's better. But again, we're probably better staying near the terminator so we can actually get a bit more detail on things. So again, even with a fairly modest telescope, you know, a lot of these features should be visible. Quite sure I'm having a few issues at the moment. There we go. There we go. But the view from where I am at the moment, there's a big lunar halo around the moon at the moment because there's a lot of ice in the atmosphere just above or in this area. And as I say, the scene's actually surprisingly good for the conditions. Again, we can see some of the ejecta from that crater here in Tycho. It's emanating outwards from it. Again, here and here. And again, you can make out some going in that direction. Oops. This is crater Gassendi, I think. Again, you can see it's quite a high walls in the rim of the crater. A few mountainous regions here. These are. I'll just push it to these slightly. West, I meant. These things here are quite interesting. They're what often, as an example, what's called a ghost crater. It's where originally be a crater, something like this, but it's actually filled in with lava. my knowledge of the lunar surface, as you probably figured out, isn't absolutely spot on. But nevertheless, and as I say, here we are back at the Apennine mountain range. The Apollo 11 landing site here. Apollo 15 landing site. I think this is this Archimedes crater. Never remember. So, a bit of a tour towards the north, you know. Not quite sure what these craters are here. Again, there's ejecta you can see here. It's obviously been an impact of some sort around here. And rather like Pete says, it's actually, I find it actually just as enjoyable, if not more enjoyable, getting these views through an eyepiece rather than, you know, from a camera. So actually, what's on attached to the telescope is nothing but a glorified video camera or webcam camera. And to take a picture, what we do, in fact, I'm going to take one now. And what we'll do is, like Pete, is I'll process this tomorrow and we'll throw it up on the Facebook page if people want to have a look at it. And we should get some nice crisp views of it. But I'll take an image now. So what we're actually doing is now capturing a video sequence. You can see at the bottom here, it's captured 147 frames. It's climbing. And it's 26.2 feet per second. And what will happen is, once we've completed our video sequence, we put it into software, which actually takes out each frame from that video sequence and then stacks them all on top of each other. And what that has the effect of doing, I'm just going to stop it now. What that has the effect of doing is actually evening out any fluctuations in the seeing. So we get a much sharper image than you can see on the screen here. So I think we took, I forget how many there, but yeah, anyway. So I've just captured a video sequence, and as I say, I will process these hopefully tomorrow, and we'll get them online for everybody to look at as soon as possible. Is that you ready, Pete?
Just about. Yeah, so the processing is what takes the time, isn't it, Ray?
Yeah. This is, dare I say it, in some ways, this is the easy part. It's what you do with the things afterwards. It can take a bit of time and tweaking. But as I say, the advantage, like anything that you automate, more things that you automate like this, more things that can go wrong. But the advantage is, in a really cold night like tonight, you can set the thing up and then you can monitor and control everything from your computer inside. So what this thing's doing...
Some of you can.
This is actually controlling the mount. So as you saw earlier, I can adjust the speed of the mount here. I can tell them which direction it goes, and I can have it, at the moment, it's tracking the moon at the speed that the moon's going across the sky. If I put it to sidereal, then it'll track things at sidereal rate. In other words, at the rate the stars go across the sky. And obviously, what I don't want to do is press stop, because otherwise this will just go scooting off the screen. But the advantage is all the software is free. And that's a nice part about it. And it's actually very easy to use. And dare I say, if I can set it up, anybody can. But it does, particularly on a night like tonight, make things a little bit easier and more pleasant. That's all I'll say. Yeah, okay, Pete.
Yeah, it's still actually quite nice to be outside looking up at the sky. And
yeah, absolutely. Absolutely.
The most important piece of astronomical equipment that you can have, though, really and truly, is a decent coat, decent socks, decent boots.
Yeah. And a hip flask of whiskey.
Yeah, I've got a bottle in the shed. I'll be hitting that later on.
That game needs to go up a wee bit, Pete.
Sorry?
I think the game needs to go up a little bit.
Yeah, I'm just going to go back to the other screen and I'll have a mess around with that and see what we can do. Get it centered as well. Right, so say we'll try it again and see what happens. A little bit too much. Let's try exposure, see what that one does. Let's say I find if you put the gain up too much, it can just become too noisy.
Yeah.
Do you know what I'm going to do as well? I'm just going to put that on.
Red filter, yeah.
A little bit too much noise there, I think.
Still
I say there's a lot of patience with this to try and get the best image you can. What else are you going to do when you're sat outside in -5? Nothing. I'm not going to turn it off again, so I reckon that's... So I'm going to check what it is like outside. That's not as good as it was earlier. Go across the left. Not seeing it yet, are we, Ray?
It's not, hang on, it should be, according to Stellarium, it should be visible. 21, 23. It should just be coming round that limb.
Yeah, that's...
Yeah.
One real good fact about Jupiter, though, if you don't know it, although it's the largest planet in the solar system, it rotates at a really fast speed. Its day only lasts for 9 hours. So if you're out all night, you can actually see the whole surface of Jupiter in one night's viewing.
And when you actually image it, it's more apparent when you image it than looking at it. Is a distinct bulge. It's actually slightly ovoid because it's spinning so fast that the equatorial regions get sort of splayed outwards. So it's slightly ovoid. Yeah.
I'll just take an image here of this, and let's say we'll try and stack them up again and get the actual images out. But then what I'll do is I'll overexpose it a bit. We'll have a look at the moons. And if you remember where the moons were previously when we looked at Jupiter, if you look at them now, you'll see just how much they have moved. And just about make out Io there at the moment.
Io's just gone behind it.
No, Io goes behind it.
According to am I on the right date? It's the 10th, isn't it? Yeah. According to...
Let me just make sure I haven't missed it. I was just coming up to the limb now.
Yeah.
That's imaged. So if we put the exposure up some there, you'll see Io. Put the gain up a bit. Well, let's try that first. So here we go. You can see this is Io, just here. And then we've got Europa has moved way further out now. So say Europa's moving that way in front of Jupiter. So it's much further away than it was when we first looked at it. But you can see Io is moving that way behind Jupiter. And it is, what time did I say it was at? 9:05, I think, is when it actually eclipsed. It actually goes in behind Jupiter. Once again, out here is Ganymede, the largest moon in the solar system.
Well, I think what you've got on the screen, Pete, is much more accurate than what Stellarium's showing. It's showing that I was behind the limb now.
You got the time set right on Stellarium, have you?
Yeah.
Yeah. Because I've got Stellarium up here and it's showing.
Oh, hang on, no.
Yeah, your times must be out, mate. I've got.
Time's out, yeah.
I've got Irish showing.
I'll tell you what is in an hour, right? Oops. Yeah.
So let's see if we can get that great red spot. So that's the case.
Yeah.
Just now and again, you have really good seeing, don't you? You can see the structure in the clouds. It's amazing.
Actually, I had mine, for some reason, my Stellarium was an hour ahead. Don't know why. Looking at it now, it's not until 9:05.
9:05, yeah.
And the GRS starts to come in.
Take some more images. Yeah, so anyone who's here new to astronomy, not got telescopes, don't expect to be seeing stuff like Hubble through the eyepiece. It doesn't work like that. You say you've got to have the expectations of what your telescope can do and what the weather allows you to do at the same time. But it is stunning just to get outside and put a telescope or put binoculars to the sky and have a look at what you can see. But it's like Ray said earlier, with just a pair of sort of binoculars, you can see the 4 Galilean moons ever so easily, and you can watch this in real time, as we are now. But when you're, with as Thomas said, mark one eyeball. It's just not quite clear enough, is it?
Is the seeing getting worse, Pete?
Let me put my head out the hatch. Doesn't look too bad, to tell you the truth. I think it's just some of it is probably the heat haze coming off of everyone's changing around here. So play around with it a bit, see what we get. I'm not really, if I check the actual lens on the telescopes, I think it could maybe that's dewing up. Shouldn't do, 'cause I've got a dew heater, but you never know. No, we're all good. I think it's just the atmosphere then. Constant high cloud around. Another part of astronomy is all this weather you've got to put up with, especially in northern Scotland. It's all fine if you're down in the down towards the equator where it's nice and warm. Zoom out again, let's see what's going on. Right, what time are we at? So we've got about 15-20 minutes before Io starts to eclipse behind Jupiter.
I found something on the moon here that might be interesting to some people.
Yep. Okay. I'll
get a bit of time on it.
We'll come back to the eclipse around about sort of 9 o'clock or something. Somewhere around about then. Let me just stop my share.
Now it looks singularly unimpressive at the moment, but this structure here is crater Messier, and you can see these tails a bit like a comet. And how this formed is a meteor or asteroids come in at a really shallow angle and hit the surface of the moon, fairly acute angle. And they haven't got, if I'd put a Barlow or Permate on, we might have got a better view of it. But essentially, it's a doublet crater, and it's ovoid because the things come in it, as I say, at a very acute angle. And consequently, it's thrown out ejecta at this in opposite direction. Yeah, I just thought it was quite interesting to see that, really. It'd be probably better visually around the point, somewhere between a crescent and a half moon. You'd probably get a lot more detail because the sun would be at a shallower angle. But I thought like that's quite interesting in itself, actually. Yeah.
There are some really interesting features on the moon when you start looking around, isn't there?
Yeah. So down a bit. Oh, I'm chancing my luck with this, but I think what happened is it came in at an angle, bounced, hit once, and then bounced in again, and this is what caused this. Again, if anybody knows any different, then please let us know. But yeah, it's nonetheless, it's quite an interesting feature.
Yeah, looks good.
How are you getting on, Pete? You?
Yep, I'm ready to go with Io. It's getting very, very close to the limit of Jupiter now.
Okay. Right, I'll stop sharing.
Yeah, so as I say, I think the seeing is coming, it's getting quite bad now because you can see how much even Jupiter's starting to shimmer around in the sky. We can see here that Io is marching closer and closer to the limb. Oops, why is that? Well, that's when I get 2 pointers, which confuses the heck out of me. So say Io is now right here. Just if I can clean this up a little bit. This is why we're struggling to find the great red spot, because the seeing just isn't there.
Where's the...
It's coming back. So right now, I'll get back to that off. We're certainly starting to struggle a little bit now, that's for sure.
The GRS should just be starting to come into view now, Pete, according to Stellarium.
Yeah.
It's just should be poking around the edge there. Just to...
It's possible why we can't see it, because that gain is way too high. We'll come back to IO in a second. Let's see what we can get here. You can actually see IO there. Can you see it there, Ray?
Yeah, vaguely, yeah. And yeah, when it sort of comes into focus, yeah.
Of course, it's going to be here, isn't it? Because it's upside down. Right. Oh, I can't feel my toes now. Never mind. Who needs toes anyway? I'll take another image just to give it a go. These are about just great. Yeah, it's nothing like what we had earlier, is it? It's really struggling to even make out the structure in the clouds now. Right, what time are we at? Still not a few minutes yet. I said one other thing about looking at the moons of Jupiter, though, and also like the occultation of Saturn last Saturday, is that you go out night after night, well, you used to when we have clear skies, when you go out night after night, you don't really see things moving in the sky. Everything seems static and never changing, endlessly the same. Because obviously our point of view in time, compared to the cosmos, is very, very small. But say when you actually look at this sort of thing and you see Jupiter and you see the moons, you see them moving, you see the detail on the planet changing, you do actually realise that stuff out there is moving around. And I'll zoom out a bit. Right, so you can see I was just there now. Very few minutes ago, just pop out of existence. Not really. Trying to get the best view I can for you. I'm just shaking all over the place. Does that look okay, Ray? Can you see IO okay?
Just, yeah. Yep. Yeah.
Just.
Yeah. It's there.
I'll turn the exposure up a little bit from there then. even with this now, we're starting to struggle. So we'll... That's my alarm to remind me of this. Yeah, if there's certain things happening in the sky, it's always a good idea to set yourself an alarm, because you get your eye to the eyepiece and you sort of forget about things, and time, what I was saying about time earlier on, time just goes away from you. The thing about this, it's not just an occultation, this is actually an eclipse, because I say about, I think about 2:05 it comes back out in the morning. I remember, what was it, 12:05? I can't remember anyway. But when it comes out, you won't see it come off the limb because it's in the shadow. It won't reappear until it's about here on the other side of Jupiter. Between there and there, it's actually in the shadow of Jupiter. Let's wish this scene would calm down a little bit for 2 minutes. I see now it's getting very, very close.
Did we stream any of this stuff to the Flat Earth Society?
I wouldn't give them the time of day. Like I've always said to them, well, when I did this, I said, "Have you ever been up a mountain?" I said, "It's not even level, let alone flat." So, about 6 minutes, it should vanish. And so if you look at what's it coming me? Where, you know, sorry, yeah, Callisto is now compared to where it was when we first watched, started watching it a couple of hours ago, not even that, hour and a half ago. It's actually said that Jupiter's so big that if it was much bigger, it would have been, would have formed it, formed itself into a star. Trying a bit of a runny nose now. What we do for our hobbies, eh, Ray?
Uh-huh.
I'm just hoping the hatch on the dome isn't froze over when I go and try and shut it later on.
It's
Let's get almost touching now.
it's -5 outside.
You ain't going to tell me that, mate. Yeah, I've lost the feeling in my fifth toe, so I know it's -5 now. So. What's happening here? Why is it going? See a correction cutting in. A couple of minutes. Just find out when it does reappear, so if you're actually up and about and feeling like it.
The GRS should be visible now.
Yeah, we'll just watch this vanish. We'll go back and see if we can find the GRS, and then I think after that we'll almost call it a night. Nearly gone. Oh, I tell a lie. It reappears at 23:15. It says here, but I think you won't actually see it until a bit later. It'll still be in the shadow. That's another thing about these apps on phones. You'll notice I'm using one tonight. The reason being is because I'm actually using a sort of computer. Therefore, my dark eye adaptation doesn't really matter tonight. But if you're outside, don't go using an app. Try and get your eyes adapted to the darkness. Don't use a mobile phone. Well zoomed in there now to actually get it to capture it. It's getting very difficult to see. I say with astronomy, you've got to be patient sometimes when you want to look at other things, like we're trying to find the great red spot there. Sometimes you can't see it, go and do something else and come back later on. The other thing you can get to see on Jupiter as well is what's known as the shadow transits. That's where the moons pass in front of Jupiter, and you actually get to see the shadow of the moon on the surface of Jupiter. They're really interesting to see. I think it's really gone. Going. That's 9:03, so any second now it should pop behind the limb of Jupiter.
Yeah, it's starting to get quite turbulent now, isn't it?
It is very turbulent. Well, I am zoomed in quite a bit, mine, so that's not helping, isn't it? But everything I say there, you just don't, if you get too much turbulence, don't try and put too much magnification to your telescope, because it just amplifies the turbulence as well. There she goes. He's gone. Near enough. Yeah, so it gives you an idea of how quickly this is sort of rotating. It only takes about 2 hours for it to go all the way behind Jupiter or in front of it if it was a transit. Gives you an idea of how fast these objects are rotating. There we have it. I think. No, we can just see it. Almost like Jupiter got a spot or a mountain. Is it about gone? Right. I think he's gone. I can't see it anymore. Can you?
Barely.
Barely, yeah.
It's almost there, yeah.
So if you want to, in an hour and a half, 2 hours' time, you can come back out if you want to yourself with a pair of binoculars and see it come the other side. Right, we'll have a last look, see if we can see the GRS. And if not, we'll call it a day. And so what I'll do is I'll put the microphones on in a little while so you can have a chat. Just for those visiting, as I say, if you don't know a lot about Sigma, you can go to our website, www.sigma-astro.co.uk. Get a lot of information there about membership. We meet on the first Friday of every month in Abbas Village Hall. First meeting is always free, so if you want to come along next month, please feel free to do so. And it's yourself going to talk next month, is it, Ray? Rightly?
Yes. Yes. I thought you were trying to promote the club, Pete.
Every time I move the screen and I got to move the telescope. I think I'm starting to get a bit of brain freeze now as well as anything else.
Difficult to say, but I bet if you imaged that, you'd probably get it in the image.
We'll take an image anyway, then we'll put some colour on. We'll just have a couple of minutes doing this. If it doesn't work, we'll give up. Or so you gotta have a bit of patience. Playing around. I think we're really fighting against the seeing now. No, we're struggling with that. We'll leave this running. As I say, what I'll do now is I'll go and I'll turn the microphones on. If you, as I say, as long as we don't all talk at the same time, it's fine. But if there's any comments you want to make or if you've got any questions, you know, to ask them. Give me 1 second on that. Let's get into the settings. Right, that should be on. So if you want to say anything or if there's any comments you want to make, please feel free to do so.
Good effort, Pete. Ray, well done.
Yeah, I was just going to say it's going to be about six minutes after midnight onwards before you see IO again. if anybody's interested. Go and have a look.
Yeah, because they say it is actually an eclipse, and not just a occultation, isn't it? It's actually going into the shadow as well, which it doesn't often do.
Yeah.
I suppose that's due to it being near at opposition, isn't it? Because all the let's say outer equator and its equators lined up. So, right, I hope you all enjoyed that.